In this lecture, I will be discussing polynomials. This corresponds to the OpenStax free college algebra textbook online, and it corresponds to section 1.4. So first of all, you have some information about some terminology you need to know. So a polynomial is an expression that can be written in the form, so it looks like this. Basically, it's a sum of terms, okay? So each real number a sub I is called coefficient. The number a sub 0 that is not multiplied by a variable is called a constant. Each product is a term. The highest power of the variable that occurs in the polynomial is called the degree. The leading term is the term with the highest power, and its coefficient is called the leading coefficient. So let's look at some examples, and I think this will become more clear, all of the terminology that we're using. So the first thing you want to do is you want to be able to identify the leading term. So leading doesn't mean first in line. It means the highest exponent. So if I'm looking at number 1, the highest exponent on a variable is a 3. That means that this will be my leading term because it has the highest exponent. So this is the leading term. Okay? The leading coefficient is the number in front of the variable. So the leading coefficient is 14. Okay, so the leading term, if I want to write it out, is 14m cubed. It's the whole thing. The coefficient is just the number in front. The degree of the polynomial is the exponent. So the degree is 3. Okay. Some of the other things that were discussed. So this is a polynomial. You look at the number of items there are separated by a plus or minus. So I have 1, 2, 3, 4. So this polynomial has 4 terms. Notice that it's separated by the pluses and minuses. So there are 3 plus or minus symbols and there are 4 terms in this polynomial. The constant term is the only one that's just a number without a variable. So 8 is the constant. Okay, and I think that kind of goes over all of the wording above. Okay, so for number 2, we want to find the leading term, the leading coefficient, and the degree. So we want to first look for the highest exponent. So notice this time the highest exponent is 5. So it's not the one that's first in the polynomial. So the leading term is negative y to the 5th. So the leading term is negative y to the 5th. And you do have to include that negative with it. The leading coefficient is the number in front. There's no number written, so it's understood to be a 1. So the leading coefficient is a negative 1. The degree is the exponent on that term, so the degree is 5. All right. Number 3 is perform the indicated operation. So for these, you just need to remember that if you're adding or subtracting polynomials, you're looking to combine like terms. That means the terms that have the same variable and exponent on them. So if you have a plus and you distribute a plus, it does not change the sign of what's behind it. So here, the parentheses aren't even actually necessary. So I'm going to start by rewriting this entire thing without the parentheses. And now I'm going to look for like terms. So first I have the 4z cubed. There's no other z cubed, so that's by itself. Next, I want to look for the z squares. So you want to go down in descending order. So you start with the highest exponent, and then you go down in order. So that's the z squares. Next, I will look for the z to the first, which is just the plain z's. And then the last thing you look for is the constant. So I've now color-coded all of my like terms. and I'm going to rewrite it in descending order. So 4z cubed, then the second highest exponent is the squares, that's in blue, so that'll be plus 6z squared. Then the green is the z to the first. Notice that these are opposites, so they cancel each other out. And then I have the yellow, which is the constant, plus 6. Now that I've added all my like terms, I know that that's the polynomial in simplest form. All right, number 4. This one is a difference. If I distribute this negative symbol, that's like multiplying everything by a -1, it changes all of the signs in the parentheses following that negative. So if I rewrite this without the parentheses, I will have 3x squared minus 8x plus 2 minus 4x squared plus 9x minus 1. So notice it changed all the signs following that minus. And again, I'm going to look for like terms. So the highest exponent is x squared. So I'm going to look for x squares. Then I'm looking for x's. And then I'm going to look for the constants. And so I'm going to combine all my like terms. So 3x squared minus 4x squared is negative 1x squared. Negative x plus 9x is positive 1x. Notice I'm not writing the coefficient of 1. And then plus 2 and a negative 1 would be plus 1. So there is my polynomial once I've subtracted them. Okay, so combining like terms. For number 5, we're going to be multiplying these two things together. So we have two binomials multiplied together. That means you're going to use the distribution property over and over until you distribute everything from the first part to everything in the second part. When you're multiplying binomials, a lot of people remember it as FOIL. So the first, the outer, the inner, and the last. But really all you're doing is distributing. So 3d times 2d, so let me get all those marks off. 3d times 2d is 6d squared. 3d times 9 is plus 27d. Now I've distributed the 3d, so I'm going to move on to the negative 5. So negative 5 times 2d is negative 10d. Negative 5 times 9 is negative 45. So now I've distributed the negative 5 to everything, so that's it. Now it's about finding like terms. Notice the middle two terms are d, so those are like. So I'll have 6d squared plus 17d minus 45. And that is the product. All right, number 6. This is actually just like number 5. It's just written in a different way. Remember, you do not just distribute the little 2. You cannot do that. That is incorrect. What you have to do is realize that this is 2 of that set. So this means 4x plus 5 times 4x plus 5. Because the square means you have that same thing multiplied by itself twice. Now all you're going to do is distribute. So 4x times 4x is 16x squared. 4x plus 5 is 20x. 5 times 4x is 20x. And then 5 times 5 is 25. Combine like terms, so you get 16x squared plus 40x plus 25. And that's it. Okay. And this is a skill. The skills in this first chapter, they're considered prerequisite knowledge. So it's stuff that you should know. But if you don't, that's okay. We're going to go over it. But make sure you spend plenty of time understanding this first chapter because it's going to be foundational. And we're going to use it over and over again throughout the semester. Okay. So number 7, same thing. So 2x times 2x is 4x squared. 2x times 1 is 2x. Negative 1 times 2x is negative 2x. And negative 1 times 1 is negative 1. Notice the middle two here are opposites. So those cancel out. And just leave 4x squared minus 1. Okay. Notice here we have 2x minus 1. Notice the 2x's are the same and the 1's are the same. The only difference is the signs in the middle are different. They're opposite signs. These are conjugates, and they will always end up with the middle terms canceling out. That always happens on those. All right, number 8. You need to make sure you use the distribution property here. So first we're going to distribute the x to everything in the second set of parentheses, and then we're going to distribute the -1 to everything in parentheses. So x times x squared is x cubed. X times -2x is -2x squared. X times 1 is x. Okay, so now we've distributed the x to everything. I'm going to do the -1. So -1 times x squared is -x squared. -1 times -2x is plus 2x. And then -1 times 1 is -1. All right, so now I've fully distributed. So now I'm looking for like terms. So I've got the x cubed. Then I have x squares. Then I have the x's. And then I have the constant. All right, so x cubed, -2x minus 1x is -3x squared. And then x plus 2x is plus 3x, and then minus 1. All right. And it looks like that's the end of the section. Make sure you practice with the examples given in the Edfinity homework, as well as practice the problems that are in the textbook.